What we're going to be doing today is taking all of our background knowledge about matrices and how they behave, and we're going to take that and try to solve a matrix equation. So when we take a look at this problem, what we see is that we have an unknown matrix being multiplied by a quantity and then increased by another quantity and is being set equal to a third quantity. But these quantities aren't just one value. What they are is a set of values, because a matrix is just a way to organize information. In this case, we're organizing numbers. So let's make our life a little bit easier, and let's call these known matrices with quantities and values in them, let's call them and label them with an A, B, and C. And I left my unknown matrix that's made up of our unknown quantities, and I'm going to leave it called matrix X. So what's happening in this matrix equation? Let's simplify it and let's really see that I'm going to have my unknown quantity X first be multiplied by my quantity A, and then it's being increased by my quantity B, and finally, after all of that happens, it's being set equal to a last quantity C. So we can connect it back to matrices. I have this matrix X being multiplied by matrix A, increased by a 2 by 2 matrix that we call B, and is being set equal to C. The matrix equation behaves a lot like the equations that we've been solving and building throughout this entire course. And just like we can read it horizontally, we can read it vertically as well. I have a quantity X, an unknown quantity that I don't know, and its first operation is that it's being multiplied by a quantity A. And after it's multiplied by a quantity A, then it's being increased by a quantity B. And then, not a quantity B, excuse me, a function B, an operation B. And it's being set equal to a quantity C. So instead of having one value change my function, what I'm having now is that there's a matrix that is changing my quantity. My quantity is a matrix. So I start with a set of numbers, my matrix X, and it's being multiplied by an entire matrix A, increased by the same size matrix B, and finally being set equal to a matrix C. So the question remains, how do I solve for my unknown matrix? Well, similarly to the previous weeks throughout this entire course, how did we solve unknown single quantities before? Well, we applied the inverse operations, and we applied these inverse little baby functions that changed our original quantity and compared it and related it to another known quantity. So I'm going to behave the same way. I'm going to first take my inverse function of B. If I add B, I can take B away, and what it's going to give me is the identity, the additive identity. And similarly to multiplying by A, I'm going to multiply by the inverse of A. That's what that little negative exponent 1 means. So it's the inverse of my original operation. And building that all together is going to have my unknown matrix X be solved. So the first thing that we need to do when we were looking for to find the inverse of adding B is we're going to subtract B, and that's going to create a zero pair with single quantities. Today, we're not finding the zero pairs. We're still going to be taking B away, but what is B? B is a matrix. So we're going to be creating the zero matrix, or creating the zero the 0, which is the do-nothing element, or the additive identity. We're going to use the additive inverse to create the additive identity. And then once that eliminates, I can see that x is becoming almost by itself. So our next step is going to be create a 1 pair. How do I get rid of an a? Well, I multiply it by its reciprocal, or its inverse. So I'm going to take my entire quantity and multiply it by the inverse of a. But instead of a being a single value, it's a set of values. We're going to create the identity matrix. So we're going to be able to solve and find our unknown quantity, which happens to be a matrix. So let's start off by taking a look at what our equation says. Again, it looks very complex, so I'm going to write above there just the little shortcuts. That first 2 by 2 matrix is called A, then it's multiplied by our unknown matrix, increased by B, which is our 2 by 2 matrix, and then finally set equal to our last matrix that we call C. So our first step is to actually add the additive inverse, which is going to create a 0 matrix, or the additive identity matrix. So I can see that if I take a 2 by 2 matrix filled with the elements 2, 4, 1, and 7, I can add the additive inverse, -2, -4, -1, and -7. And what's that going to do is create 0 matrix. If I do it on the one side, because we're maintaining equality, I need to do it to my matrix C as well. So 2 increased by -2, and finally I'm creating a 0 matrix, which changed my matrix C. So the 0 matrices go away, and I can now see that because I took B away, I took it from the left side, and I took it away from the right side, that now it is gone. It is the do-nothing matrix, and it eliminates from my problem. So again, from our previous steps, now that I have my unknown matrix being multiplied by matrix A, I need to create the identity matrix through multiplication, the multiplicative identity through a matrix. So in order to create the multiplicative identity, I need to use the multiplicative inverse of A. So we won't show you how we got the matrix itself, but it is the quantity 2 by 2 matrix, -1, 1, -3, 2. Now the reason why we put it in front is because when you are multiplying matrices, it is incredibly important to remember the order in which you multiply matrices, because multiplication through matrices, matrices through multiplication is not commutative. So it does matter if you multiply 1 from the front versus 1 from the back. Your answers will not match up, and they will not be accurate. So when I multiply the inverse of A by A, and then by x, my unknown quantity, and have that set equal to the inverse of A multiplied by the matrix C subtract B, which we have already there, we can show that the inverse of A multiplied by A leaves us 1, or the identity matrix, and which we have right there. So we have the identity matrix multiplied by our unknown matrix X, Y, Z, and W. And we're going to perform matrix multiplication on the right side. Now to get our first element, we use our first row in the inverse of A times the first column of the second matrix, C minus B. And how that behaves is we take our matching elements of the rows and columns and we combine them through addition. So we'd have -1 times 0 increased by 1 times 2, and that simplifies to 0 and 2. And we, again, for our second element, use the first row, but now the second column. So we take -1 times 8 and increase it by 1 times 11, and that simplifies. For our third element, we use the second row of the first inverse A matrix and multiply it by the first column. Take their matching elements and increase them together and combine them together through addition, and that simplifies to 0 and 4. And finally, with our last element, we take the bottom row and the second column and we multiply them and then add them, and we simplify to -24 and 22. So when we take the identity matrix, multiply it by an unknown matrix, anything multiplied by the identity gives you itself back. So through simplification on the right-hand side in our 2 by 2 matrix, we are going to discover that our elements become single quantities. And now that we can see that we have a set of 4 values being set equal to our unknown values. A matrix is just a way to organize data. So our elements correspond and correlate to each other. So our x unknown is actually equal to 2. Our y unknown is equal to 3. Our z unknown is equal to 4. And our w unknown is equal to -2. Now that we discovered our solution, we need to go back in and check our work. So our unknown x matrix, I'm going to disregard those labels now because now we're just fixing and checking our work. So now my x, y, z, w element matrix that we originally called x, I'm going to replace with the quantities that we found them to be. And we're going to follow the order of operations now. Matrix multiplication happens first. So we take our rows and our columns and we add the multiplication of the matching elements. So our first row and our first column, 2 times 2, is going to be increased by -1 times 4. For our second element, which is 1, 2, we take the first row and the second column. And you can see that we did multiplication. For our third element, which is the second row, first column, which is element 2, 1, we took the second row and the first column and multiplied the matching elements and then added them together. And our last element of our matrix is 2, 2. So we take our second row, and multiply our second column, the matching elements, and then add them together. So simplifying, we get 4 added to a -4, and it becomes 0. Our second element, we have 6 increased by 2, makes 8. And our third, we have 6 increased by a -4, which leaves us with 2. And our fourth element, we have a 9 increased by 2, which leaves us with 11. So now that we have our solution for the matrix multiplication, we can eliminate this because that's what our answer was, and we can see that we have to add a 2 by 2 matrix and see if it is equal to our last quantity. So when we have matrix addition, we take the corresponding elements and increase them together. So we have 0 and 2 leaves us with 2. 8 and 4 leaves us with 12. 2 and 1 leaves us with 3, and 11 increased by 7 is 18. So in fact what we did find is that they are equal to each other. So our solution of x, y, z, and w is accurate. We maintained equality and proved we found our unknowns. So next time when you have an equation, you don't need to become overwhelmed with what that original equation looks like. If we take a step back and remember everything that we've been taught And we all know how to add. We all know how to take away and multiply. Those fundamental ideas of creating the additive identities by using the additive inverse, or creating the multiplicative identities by using the multiplicative inverse. Using those fundamental ideas will always give you a good foundation into identifying and figuring out what you're looking for and your goals of your unknown quantities. So rather than looking at this complex matrix equation, take a step back and see that really all that is created and all that makes it up is multiplication and addition. And you can figure out this solution.